All right, how are we doing today? Doing good. Welcome to the PCB Design Lab. So we're going to be using KiCAD today. KiCAD is an open source free PCB design editor that you can find. Let me see. We're going to be using this document a lot. So this is Rev 2. I put Rev 2. I put a lot of good work into this. This took hours. So anyways, introduce KiCAD. Free open source PCB design application, go over the basics, and we will be fabricating, okay? There's a firm due date. I think I need to pull this up too, okay? Let me pull this up. And I think I need to change the due date because something else is happening too. So here's my Monday labs, okay? This is my Monday lab special. So I'm going to go over the design lab, okay? We're going to walk step by step, and by the end of this 2-hour and 45-minute session, a little less, everyone should at least have a good layout, schematic and layout, okay? Is that good, everybody? So point is, I'm doing your guys' post lab in a way. All you're going to do is take screenshots, talk about what you did, because in the end, a lot of you are going to be looking at PCB designs for your senior design, okay? Senior design, Dean Venkat, Dr. Greg, if you guys remember him, Dr. Ming Zhu, they're like, the biggest thing was seniors don't know how to do a PCB. So that's where I came in to redesign this lab to include fabrication, because I think fabrication is a very important thing that we do a lot in industry. If you do IC design, you print your thing. If you do mechanical engineering, you have to print the metal piece, right? Or 3D printing at least. From design to implementation. The implementation is the one that makes money. Is that correct with everybody? Anyways, for you guys, we're going to go over the lab, okay? And then for those who haven't finished, don't worry. I have this recorded, okay? So do please talk with the TA about that, okay? And then let's see, what did I say? Yeah, start lab 5 at home as your pre-lab. Makes sense, okay? Next week, we're going to have a firm submission. I'm going to be ordering these boards. This is the only due date I can't change. So I'm going to be swiping my card. I made a call with Oshpark. That's the vendor that I'm going to go with to purchase all these boards in one big go. So they're giving me a nice, really good discount, okay? So that's a day I cannot extend. I'm going to be purchasing all these things. So let me see. Fabrication. Let me just silence this. Okay. Always put your phone on silence. Anyways, I'll purchase these boards, all right? And then while you guys go to spring break, right? And then I think I made the post-lab due, right? Post-lab? I think I need to change that. That's the thing I need to change. The post-lab is due... what do you call it, that day of your submission. You guys like that, or should I make it midnight of that night so you guys can edit it a little better? Midnight? Because you want to know why I'm trying to make it due like that week, everything's super strict, so you guys can go on spring break. I don't want you thinking too much about like, hey, what's my pre-lab, what's my thing, okay? I want you guys going, like leaving this lab next week being like, woo, everything's done. I don't have to think too much. Well, I'm working on a frequency response lab. That one's also an easy lab, okay? It's not too bad. We're going to be drawing Bodhi plots, okay? And I have a special machine. It's not here. It's in another room that does a Bodhi plot for you right then and there. So these next few weeks should be a little more easier. And then right after week 6, it gets easier, okay? Not too bad? Anyways... let's go through the lab. So if you started, great, that makes it easier, but I'm going to polish it for you guys. For those who like say, I don't know what's going on. It's okay, don't worry. So I made a folder here. This is where I'm going to design all my stuff. KiCAD PCBs, let me click on this. Okay, KiCAD PCBs. I created a directory. This is like my directory where I'm going to throw all my work. Senior design project, side hustle project, a personal project or a research project, right? Create a folder, okay? This is where you're gonna put all your PCBs, and you see right here, I have a few folders. I have Senior Design KiCAD Demo folder. This right here is called Downloaded Parts. It's a surprise for later. This is my first PCB, okay? And then you can click on it, and then boom, you can see some cool stuff that I generated for this class for your lab report. What time was I up on? 2:13 in the morning. I care for y'all, okay? I want to make sure you guys do your work, okay? So the first thing you're going to do, let's read through this manual. Not that one. Let's see. Because I'm also using this class to help me edit my stuff. Okay, got diodes, got all these other things. We're going to be dealing with the op-amp chips. I forgot to add one more component. It's okay. Go to KiCAD.org. If you click on this link right here, it takes you to their website. Donations. No, I don't want to donate, but I can. Click on download, all right? You see, look at all this stuff. Docker. So if I used the Docker in the past. It's a little painful, but it's really, really cool with integration. But you can use any of these other things. So I'm going to click on Windows. And then let's see. I think I used the MIT download. Is that what I did? Or no, I used GitHub. Same thing. So click on that. I've already had it downloaded. And click on that. Press here. Click on next. KiCAD version 9, right? But I think we're on like 9.27 or something. I don't know. I'll check that out, okay? Should be the same for everybody, all right? Click next. Click for me, okay? Unless you want to do for anyone using the computer you're using. If you're using a private computer like your own laptop, go ahead, be my guest. You're at the admin of your laptop. Start with default settings. If you already installed KiCAD, you can click on, what do you call it? Import your previous settings, okay? So if you've already downloaded it, but if you're going through my tutorial again, just import your previous settings, like your keybinds, your board design, whatever fabricators you're using, just click on import settings and then it goes, okay, because look, I had version 8 and they just came out with 9, so I was like, what the heck? So, which is good, it's great. So I had to import it, but I'm doing it for fresh, okay? I'm the student, okay? We're going through this lab. Everyone good with this part? Can everyone download KiCAD for me? Or is it, if you're using the computers here, I think they should have it installed. Is that correct? Yeah, the computers in this lab? Right? Or no? Okay, perfect. Okay, but if you have your own laptop, personally use that. By the way, these PCBs are going to be team-based, okay? So it's going to be one PCB per team, okay? It's not in 2 individual ones like, oh, everyone's going to do an individual one. It's a team effort, okay? So because I'm trying to save on money too. I wish I can do individual ones, but that's way too deep into the budget cuts, all right? So anyway, so if your lab partner's doing it and you're just watching, that's fine. But try to take turns between learning the tool. If you want to use this lab right now to look at it and then maybe edit it a little deeper, so please be my guest. Some of you will be using this for your senior design. Some of you are probably never going to use this ever again. But my job right here is to give you this tool to at least show you that you can do some stuff. Is the PCBs being passed around? Right? You guys like the cactus? You guys see the little Shrek thing? Yeah, you can do a lot of cool things with KiCAD, okay? Right after this, you guys can go make a business, all right? Anyways, let's open KiCAD itself. So if you've already had that download, I let people download it for now. Go to KiCAD. I have version 8. I have version 9 here. I'm going to click on this, okay? I'm going to click on a new one, all right? I'm unique in a way because I already have a project. If you're trying to make a new project, click on New Project. And then this is where I'm talking about, okay? You see right here, I have KiCAD PCBs, okay? I'm going to save in KiCAD PCBs, okay? This is where all PCBs I ever design are going to go here. I'm going to call this one, I'm going to put a new folder, right? I'm going to call this my EE320 Lab Monday Special. Okay? I'm going to save it in that folder, okay? So you're going to create a new folder, all right? And you're going to save it right there, okay? So let's see. I'm going to save it right here. Boom, boom. Hello. Let's see. Why is it not saving it for me? Create new project. Oh, wait. Let me click this. If I, give me a second. Click, copy. Then I'm going to go into that folder. I'm going to paste, save. There you go. So I created a new folder, right? I created, what do you call it? It's called .KiCAD_pro for project, right? This guy right here, you see that right there? Okay, so let me just go to my folders, okay? I'm just gonna show you. Boom, it's right there, okay? Double click. Oh, wait, wrong one, wrong. There we go. Boom. I guess it created a folder for me. Anyways, it created a folder for me. I learn a new thing every day too, okay? Anyways, let's go to our schematic, okay? The schematic editor is right here, or you can click on this button right here, or you can click on this. Oh, there you go. I clicked on the schematic button, and yes, it did open that folder, okay? So let me do it again. Exit. I'm going to click on schematic editor. You can click on that button, or you can just double click right here, and it should be the same. Yeah, same thing. Is that cool with everybody? So there's some cool things about this. Let me just see through my thing. I will save it to a folder, call my project My First PCB, whatever, okay. Yeah, that's what it should have happened, okay. See, here's your project, here's your layout, here's your schematic, the 3 most important files, okay. Let's create a circuit, click on this piece or click on this button right there. If you get this pop-up right here, you can copy default global settings, press OK, okay. What else did I do? Was this a really nice lab report? Instantiating components. If you can press the A button or this button right here, right? I'm gonna press this little op amp button. You guys like op amps? And I think we're gonna create a voltage divider. Is that correct? Let's see. KiCAD is very, very heavy, so just let it do its thing. Okay. Hands in the air. There we go. So I think, let's see, there's a few pieces in here. I'm going to go to res for resistor, right? Not resonator. Is that good? Let me see. Device, sensor, potentiometer, my resistor. Where's my through hole? Let's type in THT. THT. Let's see. What did I do in my manual? Did I say how to find it? Let's see. Yeah, resistor R. Generic. Oh, sorry. I'm thinking something really different. Okay. You guys like that little resistor right there? What about this one? How about this one? Cute. What about this one right here? The American version. US. Pretty cool. What's this one? Photoresistor. Thermistor, shunt, US shunt, not too bad. Let me see. You know what's funny? I'm thinking this right here is the international resistor, and this right here is the American resistor, because yeah, that's literally what it is. So point is, they're both the same. This is just a visualization of your schematic, okay? So because for clarity, I'm gonna click on OK right here. Okay, is that cool? And now, here's my little resistor. I'm going to press R. Let's do that. Okay, R for rotate, okay? Is that cool? Click, and there's my resistor. Ta-da. And then, let's see. I'm going to press escape. Now I got my mouse tool. There's my resistor. If I click on the resistor and I press Control C and Control V right here, boom, it gives me that, right? I'm going to press R again. Boom, right? Liking it? Liking it? Now I'm going to do a wire. I'm going to press W for wire. And if you press W anywhere, watch this. If I press it randomly like right here, look, boom. Cool? Nice? Anyways, click W. Boom. Click W again. Boom. You can press W again right here. Or you can just click. Is that cool with everybody? Right? So yeah, the W2 is a little weird because it just does whatever it wants. I'm going to put a W right here. Boom. Or you can, double click right here. And then it turns it off. You have to press escape after that. Is that cool with everybody? Okay, so now let's introduce to you some labels. So if you press, is it L? L for label. I'm going to do V in, right? Right? And then I'm going to do label again for V out. Enter. Boom. Is that looking like a voltage divider? Kinda. We need our ground, right? Place symbols, correct? GND. And then you got all these other grounds right here. Why do I need multiple grounds? Because sometimes you might have different grounds. You might have like AC ground, DC ground, noisy ground, analog ground, whatever ground you want, okay? KiCAD gives you unlimited supply to label whatever you want. For our purpose, let's call it, oh, you can even call it Earth too for something. Yeah, GND. Is that cool with everybody? And then let me see. How do you, let's see. Zoom to fit is the home button. Well, my computer doesn't have one. So what's the other button I have? Nah, I don't want to do that. Anyways, if you have a mouse, you can press Control mouse wheel to go left and right, Shift mouse wheel to go up and down, and then the actual scroll wheel itself to zoom. What else do we have here? Now we need to make this a real component. Let me see. Did I talk about that? Yes, I did. Rotate, rotate. Control S to save your work. So right here, just save your work. Congratulations. Boom. Okay, auto backups. You guys saw the auto backups. I'm not going to go over that because that's going to be on your own end, okay? There is a chance that KiCAD can crash on you. So if you have like a not so new laptop or computer, this may be more helpful. But if you're running on the servers here, I don't think they should crash. But if you need to do auto backup, there you go. If you want to have dark mode, you can. You can go to preferences, click on dark mode. You have to download it, I think. Yeah, downloading dark mode. And then you get schematics that look like that. Pretty cool. I'm not going to go over that, okay? Creating components, connector, press W. We need to have labels, press on L. Is that cool? I'm going to the lab, right? I'm verifying that this lab can work. Creating power symbols. Oh, there's a button here. Let me see. Let me press it. GND. Power symbol. I think I know what's going on. Give me a second. Maybe this one might be funny. I'm going to delete this, okay? And I'm going to use this power ground instead. GND. Creates up, okay. Global power. Okay, I think I know what's happening. Boom. There we go. We're good. To add an input, something we will use. Where? Okay, boom, boom. Let's label global label. Control L. Input, output. Is that what I do? So you can do this or this, but let me see it because I think I have a comment about that. Adding headers. Let me see if I talked about the resistor a little deeper. Give me a second. Was this a nice tutorial? Let me see. Okay, no, I don't talk about the resistor components. Let me just show you this one. So how do I probe into my PCB? You're going to need headers. You're going to need some copper. You need some actual components. So I purchased special components. There's these little green headers that you guys probably saw around. Let's see. I purchased some nice ones here, okay? So KiCAD doesn't really know what you're talking about other than just symbols, okay? You need to assign those footprints. So let's add a connector. Press A and type in con. Okay? Press A, type in con, and then let's look for, is it this one? There we go, 1x2 pin. Okay, and you see there's no footprint here, right? And then, oh, look at this, there's a bunch of footprints here, but I purchased a footprint, okay? Or a special thing for you guys. Put this right here. Is that cool? Let me see, what else do I have? Add the symbol. We need to connect this to this and this and that. Does that make sense? So let me do this. I'm going to do this. Control L. Okay, I'm gonna do this. VN. I'm just following the tutorial. Okay, I want to generate the same errors. RR. Boom. Double click on that. It's an input. Okay. Oh, is that it? Nah, whatever. Okay. Is that cool? I'm gonna press W here. Boom. Put this right here. Boom. I'm gonna do this because I'm a little lazy. Copy paste. Oh, come on. Copy paste. Copy paste. Click right here. Is that cool? Check and save, or just save. Is that cool with everybody? If you want to know where your nets are, you're gonna go to senior design. You're gonna have like a big microcontroller, and you're gonna have so many things to paint. So if you want to verify that, you can press this right here, highlight nets. Boom, it's connected. All right, it's gonna be connected, and it's gonna help you for your layouts. Okay, escape to get out of that. Connecting symbols to footprints. This is the most important part. Okay. So we do have components in the lab. We have op amps, we have LEDs, we have resistors, right? But you're gonna probably want to do a personal project where you're gonna download something online. You're gonna purchase a part. We may not have these parts for you, so you're gonna have to probably go online to download them. Okay. But first, resistor. Resistor is the most basic component, so this KiCAD will have it. So we need to assign it a footprint. A footprint is just a real component. Okay, let me just see. Physical representation. You will be using, did you know that you are using quarter watt resistors in this lab? Quarter watts. Okay, there's half watt, quarter watt, a tenth of a watt, 1 watt, 10 watt. So there's different footprints for each one. So let me see, what did I do here? And then this is important too, because this right here, you need to start measuring stuff, but don't worry, I'll give you the cheat answers, okay? Quarter watt resistor. It's an axial resistor because it's got an axle in the middle. Let's see. And then, what do you call it? You can get a bunch of sizes. So if you needed help with figuring out what resistor you're going to be using, just look at this chart, or you can measure it with a caliper, okay? And KiCAD should have it for you. Let me see. You guys like that resistor right there? It's okay, right? Let me see. Let me see if I had another one. What about this resistor here? What did I say about this? The falling resistor may be more forgiving if you're still practicing soldering. So if you're a solder wizard and you know what you're doing, be my guest, you can use this smaller footprint. But you see how tight that is? Right? It's really tight. So if you're not really good with putting it like the leads through the holes, you may want to use something a little more forgiving. You see that right there? This is what's going to happen in real life, okay? So I'm going to double click on the resistor, right? I'm going to click on footprint. Click on this book right here, this book like shelves or libraries. Let's go to resistor. Okay, these are called SMDs, surface mount devices. These are the pins that you see. Do I have a microcontroller? No, I don't. But basically, they don't go through a board. It's just paste, and you have to find the component. These are tiny. They're like, I don't know, smaller than a grain, like half a grain of rice. Okay, you can use that. I think we have a few of those components, but I'd rather everyone solder like professionally with like actual soldering irons. Okay, so don't use this library here. THT, what does that stand for? Through hole? I don't know what the other through hole. Whatever. Anyways, let's see. What's our first one? Vertical resistor. But we need a horizontal resistor. There you go. I'm going to click on this right here. R underscore axial. The 204. It's got a, what do you call it? A body of like 7, or what do you call it? 7.62. Is that a good number? I'm going to click this one, okay? Double click. And now that's been assigned. Is that cool? Everyone following what's going on? There we go. So now this thing has a real life representation, okay? Footprint, value, reference. You can put a data sheet too. If you have a data sheet that you downloaded from, I don't know, somewhere on the internet, you can tie lots of documentation so that when you can zip the file to somebody else, like, I don't know, some industry partner, some other teams, they can have the data sheet too. All right, KiCAD can do a lot of cool things. I can't explain them right now, okay? Let's do it for this other resistor footprint. Boom. I'm gonna do THT resistor. There we go. Oh, look, gives me a recently added, so I can just click on this and I'm done. Cool. Now we're getting real life components, okay? We're making it real. Okay, let's go down here. I downloaded a footprint, okay? I put this in the lab manual because I'm trying to train you guys that KiCAD may not have your part, okay? Sometimes you're going to 3D print your own parts, or you're going to do something cool for senior design, or some funny physicist is like, hey, can you do this for your senior design or research project? So you're going to have to either download a part or something, okay? So here's a pin header, okay? If you click on this link, and this is very, very important, okay? You're going to be doing this a lot in your senior design. How do I build this in KiCAD? Let me show you. I click on the data sheet right here. Let it do its thing. Wiggle, wiggle. It gave it a funny number, right? Don't you just like UNLV Wi-Fi? So there's a footprint editor. We can design our own footprint. You can design your own. So like it's a CAD software, okay? The manufacturer, your physics professor or research professor is going to give you like weird dimensions, or you have a caliper, okay? Dimensions in millimeter, right? And boom, you can do a lot of cool things. Like here's the length plus or minus this. Boom, not too bad, right? Gives you the size of the hole, right? 1.3 millimeters in diameter. Is that cool? So you can design a lot of cool things, okay? Some of you guys are like looking at me like, I don't want to design. That's fine. I'm going to show you a cool trick. But for those who want to design, this is right here, okay? So I'm going to show you the cheat way. A lot of components on DigiKey give you this file right here. Let me just zoom in. I won't let me zoom in too. See right here? EDA our CAD models. Click on this. And it'll give you, let me see, let me zoom out. It won't let me zoom too badly, whatever. Hello? Refresh. There we go. Boom. They'll give me a 3D view, right? I don't want that one. I want the symbol and the footprint. What about this one? I'm on one of these. Hello? Well, I'll give you some funny news. So let me see. What did I do in my lab report? Let me check, because maybe I'm seeing things, seeing ghosts. Yeah, tedious. Boom, boom, boom. Download this. Oh, 2D model. Okay, great. Whatever. Okay. What did I click on right here? Was it snapmagic.com? Click on SnapMagic. Click on that one. Select download. You're going to download the step file, and you're going to download the 2D model, KiCAD V6 and later. We have V9, okay? Download, and I'm going to re-download it. Whatever, it's fine. Do I? Should I? Oh, okay, there we go. Oh, downloaded it twice. Great. Open this. Exit. KiCAD. So this is where I have the downloaded parts. So we're going to download a lot of cool things on DigiKey, okay? So create a folder in your KiCAD PCBs, right? You're going to create a folder called downloaded parts, my library, whatever you want it, okay? This is where you're going to put all the stuff you want to buy. I'm going to buy, I don't know, some cool LED right here, potentiometers. Let me show you. Anyways, but you're going to see all these chips too. You can build, or actually, let me see if I can show everyone this. Oh, it broke now a little bit. See, look, see this button right here? I think KiCAD has this button itself, But if you wanted to, you can find this on DigiKey and boom, be my guest, okay? There's a lot of freedom here, but I'm trying to make sure this class is more into one direction, not too bad. Okay, let's see. So, do I want to download it for you? It's okay. Here's the folder. I think, is that what I called it? I'm going to redo it again. So, here's my download, okay? Give me a second. Downloads. I don't know why I downloaded it twice. I'm going to click on this. Control X. Go to KiCAD right here. KiCAD PCBs. Downloaded parts. Put this right here. I'm going to extract it all. Extract. What the heck is this? It's garbage. It's a step file, but I don't like this. I'm going to call this one something funny. I'm going to call this one 2-term 3D block. Or I know. 3D block. Let's see if it does something. I'm going to download. Let's look at the other one I got. Download. Here's the other one I have. Actually, before I do something funny, let me just call this one downloaded. Boom. Control X. KiCAD PCBs. Downloaded parts. Paste this right here. There's my downloaded file. Delete all the zip files, by the way. You don't need that anymore unless you want to really keep them and send them to a friend. I don't need this @mega part. Extract here. There you go. That's a lot better. So the 3 important files you need. Let me see. It's okay. Is the .kicad _ mod, the mod file, the symbol mod file, and the step file. The step file is your 3D viewer. The symbol is the actual symbol in like your schematic. The mod is the footprint. Is that cool with everybody? So now I need to put this into my KiCAD, okay? Let me just get out of there. Screw this one. So you see this con, right? Let me see. Let me do something funny. What did I do in my lab manual? How to import. Okay, what did I do? Symbol library. Okay. Oh, okay. Cool. So let me show you what I'm going to do. So I'm going to go back to the KiCAD menu, the main menu, right? This guy right here. I'm going to click on, I'm going to show you a shortcut because I don't want to waste time. Preferences, manage symbol libraries. Okay, I'm going to go down here. And then you see all these new parts I downloaded. I can use a lot of parts. These are all parts I've downloaded. My ESP, LM741, all these other cool things. Video valve, nice. Click on this plus button. Let's call it, I don't know, 2-term 320 lab or whatever. Okay, is that cool? I'm just going to call it this, okay? Because I already have one right here, but I want to show you what I'm doing, okay? So there it is, but I need to put a library to it. There's this little folder right here. Click on it. Let's go here. Downloaded parts. Where's my, what do you call it? Where did I put it? Is it right here? Downloaded, right? I downloaded this part, right? I'm going to click on this right here. And there's a symbol. Boom. Okay, all you need to do is label the symbol, and you're done. Boom. Cool. Now, press OK. It's going to do its magic. Magic. It takes a while. I'm just showing you what's going on, okay? Boom, you're good. Let's do our footprint itself. Let's go here, footprint. Go all the way down here. I'm going to press the plus button. I'm going to do, what did I call it? 2-term 320L, right? Dash 320L, right? Click on here, folder. Downloaded parts. This is the part it's called right here. I just called it download or whatever, okay? And you're gonna not see anything, okay? But I'm gonna show you what's going on. You see this folder right here? That's where I saved it, right? Is everyone following? These are the files, right? This is the file that I want, this mod file, right? KiCAD underscore mod. Do you see that it's not there, right? It's just looking for a folder, okay? I'm gonna click on this. Don't worry, okay? Trust me, bro. And then click OK. Let it do its thing. Cool. Anyways, I think I want to cheat this a little bit. Let's go to the symbol editor. Before we do that symbol editor, let's go to PC, the footprint editor. Okay? I want everyone to do this with me right now, okay? So we're in the footprint editor. We're about to design the actual footprints, okay? So let's find that footprint that I called it. It was called, what was it called? 2-term, right? 2-term dash 320L, right? That's what I called it. I'm gonna click on this right here, double click. Boom. Does that look cool? You like that? Let me click on 3D viewer. Nice. But we're missing a component. Where's the thing? I downloaded it, I found it, right? It's not there. Dave, where did it go? I'll show you. Go to footprint properties. Let's go to, okay, here's the footprint properties. You can do a lot of cool things. If you wanted it to be on F silk screen, that's a secret for later. You can put it on the silk screen, the top, the bottom, whatever you want it, okay? So you can, actually, let me click on this. Whoa, ooh. I'm learning, lab director. Click on 3D models. Right? Let's add the .step file, okay? I'm gonna click this plus button. And we gotta find that file, okay? Let's go to downloaded parts. Download it right here. .step, correct? Open. There you go. Looking cool? But now we gotta fix it. So let's do the following. We're gonna play with this. So let's rotate it this way. Maybe this way. What did I put as my numbers? I'm too lazy. You guys have trouble with this too? Where did I put it? Where's my header? Header. There it is. Connecting footprint with 3D model. See that right there? My tutorial? What's the cheat answers? -90, 180, 90, and this. -90, 180, 90. Okay. Let's do -90, okay? 180, and 90. Okay? You guys like that? This is looking cool, right? It's not in the hole, though. So let's offset it a little bit. Offset it there. You guys like that? Looking cool? Is it going to fit the hole? Yes? You're going to do this with a lot of cool parts, okay? We're going to make some really cool boards. Then let me click on OK. Don't forget it. This is the master footprint, okay? Do it on the master footprint. Don't do it on individual footprints. Do it on the master, okay? Else you're going to have to do this like 1,000 times. Catch it right here, one time. Press the save button. Boom, you're done. Let me go to my symbol because I'm going to catch it again. I'm going to look up 2-term dash 320. There it is. You guys like that? That's my master symbol, right? My master symbol. File, symbol properties. Footprint. Ooh, I did an oopsie. Because we renamed it a little bit, we need to rename it on the master symbol. Else you're going to get a lot of errors. And you're going to call me at midnight and be like, David, I can't do it. I'm like, I talked about it. I'm going to click right here on the library right here. We need to find that, okay? 2-term. There it is. Do you see the name right there? Right? It's the numbers, colon numbers again. Watch this. Click here. Watch what happens. You see how I renamed it? It's because we renamed the actual like the library or the folder, right? If you can, you can't. It just depends on your flavor, okay? You can do a lot of cool things to make it easier for you to like remember what's my piece called. All right? Okay it? That's your master symbol. Okay? We're saving that on the master symbol. Boom. We just cut like 30 minutes of headaches right there. We can exit out of there. Let's get back to work. So you guys like this connector, right? I know, I liked it too, but we're gonna have to nuke it. Delete. It's gone. Let's press A. And let's go find that connector. 2term-320, that's what I'm calling it. You see that footprint right there? Or symbol, footprint? Cool. Okay it. Press R. I don't like it that it's 2-1. Whatever. Is that cool with everybody? Any questions? Save. Woo! I think we're done. Is that it? Let me check. Let me see. Was that really it? Okay, let me check. Okay, we're gonna need a power flag. But okay. Like that? You like that? Okay, we're good. We're going ERC. Let's do an ERC, okay? I want to generate something funny. ERC stands for Electrical Rules Check. It's going to just check if it works. Run. Aha. It says it needs to be driven by power. So all we're going to do, let me just check. How did I fix these problems? Adding a power flag to ground. So if you want to fix that problem, press on A, right? Or did I put that somewhere here? Is there a button here? I don't have a power flag button. Press A. Power flag. PWR. There we go. Power flag. Okay. What about this one? Just do power flag. Okay. I'm gonna press R. Stamp that right there, right? Let's see if that fixed that. Let me just run the ERC. Okay. Local and global labels have the same name. So what should I do? Just delete this, whatever. I want to go home. What? Unconnected wire endpoint. You want to know how annoying KiCAD can be? It's a little annoying. You see this square right here? You see this right here? Do you see this? If I just click and drag, let me just click and drag. I'm gonna click on this. Delete. I'm gonna press W here. And watch that error disappear. It's so... I know. It's a really silly error. Did you catch that? Really cool, right? Littlest things, okay? We're done. We're done with that part. That's Rev 1. Should I cheat this way or should I go through the manual? Cheat. And now let's go through the manual. I want to make sure anyone who watches this video can do it at home. Save. We're ready to design. Let's go to... Do I have a special button here? Where's my special button? Where is it? Where's that button? I don't have that button. Give me a second. From the schematic, switch to PCB editor. Where is that button? I don't have that here. I think my resolution is so small. Let's go to, let's see, tools. There we go. Click on tools. I'm learning too, okay? I'm a student just like you. Switch to PCB editor, right? Or you can press, there's no other button. Just press it. Okay? This right here is the layout editor. We're about to make some real components, okay? So let me just see why. Okay, there we go. So here's the next important part. Here's the easiest way to get your PCB done. Click on this button, update PCB from schematic, press on it. Boom, boom. I think you should run it. Run with no errors. Close. And look at this. I'm going to click right here. There's our components. Like that? Why is this small? I don't like this. Wait, hold up. Give me a second. What did I do? .3, 2.5, 7.62. Let me just check something, okay? Double click. Oh! You see this right here? 3.6, 1.6, 7.62, right? And then I was looking at this, I was like, what the heck? It's small. Right? My manual is 6.3, 2.5, 7.62. Okay, I'm going to teach you a special lesson, y'all. Lab director can't teach. Boo! Anyways. Don't worry, easy. 6.3 right there. Right there, that's a lot better, okay? I'm going to click on that one. Double click on this one. See, 3.6, I don't want that, it's too small. I'm going to make it a little bigger. 6.3, so double the size. And let's choose 10.16. Happy soldering. Save. Now I'm going to go back to my layout editor, okay? It didn't change, okay? It didn't change. So I'm going to update from the PCB, or update PCB from schematic. Watch this. Let's see if it changes. Boom, it did. Okay, so if you make a little mistake like that, don't worry. Just keep updating from your schematic using that button, okay? You see that right there? Cool? Do you see the difference between, Control Z? The difference between this resistor and this resistor? Which one's going to be harder to solder? Maybe this, I don't know. You can say this one's hard. Okay? Your flavor, your soldering lab, your choice, okay? All your freedom, all right? So, what's the next part of my little lab tutorial? What else did I do? Oh. Yes?
For that like footprint editor portion, do you know where that is in like the lab report? Or where that's found?
Oh, in the footprint thing?
Yeah, when we went into footprint editor.
Footprint editor? Well, if I do Control F, footprint editor, or... Oh yeah, there you go. Figure 1, 2, 3 on page 6, 7. Did you set me up? Page 6, 7.
Thank you.
I'm not joking. It's right there. So you click on footprint editor. You you can go to footprint properties. Do that problem right there. Is that cool? So I'm just I'm using a mix of this manual plus trying to make you guys finish this lab today. Okay? Is that good with everybody? Because I think we can cheese this in like another hour and a half, hopefully, okay? Where was I in the manual? Can anyone help me? Let's see. There we go. Okay, we got to reorganize our layout, okay? So let's make it look pretty. So I'm going to put it right here, put it right there, put it right there. Is that cool with everybody? Right? So let's do that. So all you do with this one is, okay, I'm just going to put it right here. And put this puppy bad boy right here. And maybe put this right here. I'm going to press R to rotate. You like that? Is that a voltage divider? You guys like it? Cute. And that's it. Yeah, that's it. Now we got to make this realizable, okay? KiCAD doesn't know what we're doing. We're going to print this out of the fabrication lab, okay? We're going to send this out to Oshpark. Oshpark is our vendor that I chose. It's really nice. They're an American-based company. Let's see. Each fabrication lab will have its own design rules. They have their own machines, okay? Like milling machine, printing machine, cutting machine, etc., okay? So let's click on Osh Park. I'm gonna just type it in, Osh Park, or just click on that link. Let me see if it works.
What state are they in?
Oregon. So I think we get our boards not too fast, or it's fast enough. Okay? This vendor can also do 4-level boards. So 2-level board is top level and bottom level. You can solder on the top and the bottom. 4-level boards, you think you can solder in the middle? Not really. You still have to solder on the top and the bottom. I think there's a fabrication that does it like middle parts. I think that's like, I don't know, some special person. But point is, you can have 2-level, 4-level, and 6-level boards. But it gets more expensive, okay? But we're just dealing with 2-level boards. So if you're designing a senior design board and you're like, oh, I want to make a 4-level board, it's going to be a little thick guy and it's like really small but really thick, you be my guest, okay? So yeah, they can do that. Solder mask paste expansion, don't worry about that. Tent vias and whatever. This is important. Every fabrication is going to have their design rules. This is their printer. You have to follow their rules, okay? So it gave you all these numbers, mills, and 2-layer, 4-layer, 6-layer boards. We're going to use the 2-layer service right here, right? Minimum clearance, track width, connection, annular ring. Oh, man, that's a lot of rules, right? Don't worry, y'all. I saved y'all. Right here. See that right there? Copy pasted. Let's see. Go to PCB editor, okay? Board setup. Right here, right? Layout, correct? Board setup right here. Right? We got to put design rules, constraints. Right? David, how do I see mills, millimeters, and inches? There's a special button right here. I need everyone to know this. Someone's going to always ask me this question. Right here. Mills, inches, 1/1000th of an inch, inches itself, and millimeters, okay? I guess a lot of American companies like, what's that word? Imperial values. So we use inches, but we're a little more special, so milli-inches, mils, right? Click on the mill button. File, board setup, constraints. Now you can put 6 mil, right? And then 6 mil right here, 6 mil right here. Dave, where are you getting those rules? Right here, right? Or you can use millimeters. Be my guest. It's your lab. Have fun. And then where did I give you copy paste? Dude, you like this copy paste? I'll update the following. See this figure and table for maximum pleasure of just copy paste, okay? So what did I do? 6, 6, 6. 5, 20, and a 5. Let's do that right there. Where did I put it? Right here. 5, 20, and 5. Okay. What's my copper to edge clearance? 15 mils. I put 15 here. 15 there. Holes. 10 and 5 is the minimum sizes, okay? 10 and 5. Okay, we can go a little smaller there. This one, you see, it gives you 9, but KiCAD is, or not KiCAD, Oshpark's a little more special. We can go to 5 mils. Microvias are only used in 4-level boards. So you can ignore this one, but honestly, let's just put the rules on there, okay? Microvias, 20 and 10. 20, 10. Silk screen. So silk screen, you have a little more freedom. Let's see. So they said user preference. Some people are very OCPD and don't want silk screens touching each other. You can set it so that there's a clearance. Like, oh, give me 5 millimeter or milli inches of clearance, right? Mils of clearance. But me, I don't care if the silk screen's touch. I'm fine. 0. I put 0. That's me. The text height, let's see. User preference, I put 30. That's fine. Whatever. And then text thickness. Let me just check if this was a fabrication guy, a rule. Let me see. User preference, user preference. Oshpark says you need to say 5 mils, okay? So I'm going to do this. 30 and then 5. Easy. That's the hardest part of the lab, okay? Right after that, you're done. You can start designing, be my guest. It will tell you and bark at you, and it'll force you to design in a certain way that Oshpark wants you to design. Okay? Well, going back to the lab. Creating wires and vias. This is very important, okay? Go to predefined sizes. I'm going to show you the cheat way, okay? Save. File. Board setup. Predefined sizes under design rules. I'm going to put, let's see. Let's do 10 mils. Let's do 20 mils. Let's do 40 mils. Let's do 60 mils. Maybe 80. Is that cool with everybody? This is the thickness of the wires. Okay, and let me just put the minimum one. What was the minimum track width? Was it 6? Yeah, I'm going to put 6. There we go. Add. Okay, just for fun. Okay? That's going to be the size of the actual copper traces, okay? The wire itself. Via is the hole, the through hole. It's going to be, you have the copper ring and then the actual hole it's going to go through. So for everybody, let me see. What did I say in the manual? Yeah, 20, 40, 80, 10, 40, 80. Okay. And I did a 2:1 ratio, right? I like that. That's fine. Be my guest to play with other rules. So let's just copy that. Press this plus button. 10, 5, right? And then I'm going to do, what did I do? 20 and 10. Then what did I do here? Was it 40 and 20? And then let me do one more. I'm going to do 80 and 40. Is that cool with everybody? And let me just do a different number. Let me do I don't know, 50. Let's break some rules. Breaking the rules. Okay? Now we got our pencils ready. We got our eraser or the hole ready, okay? We're ready. We're setting up everything. It makes our life so much more easier after this, okay? 6 mils is the smallest wire to do, smallest via, In reality, we're going to use 20, 40, and 80 mil traces because current is going to be going through these paths, okay? So if you make your trace too small, the current, if you have 1 amp going through your wire, it's going to burn it. If you make your track too thick, if you have a baby signal, it's going to get eaten up by the copper, the capacitance, the parasitic capacitance in your copper. Okay, so be cognizant about what you're designing. If you're designing something that's like analog sensitive signal, use a smaller wire, like maybe like 20 mils, 10 mils, or something like that, 50 mils. Like for CP, like you're doing, or not CP, EEs, amplifiers, right? If you're a CP and all you're doing is like zeros, ones, you can kind of go away with like more. You need more current. So you're just dealing with like, zeros and ones, 20, 40, 30 mils are fine, okay? If you're dealing with power electronics like motors, right? Motors, relays, all those things that need like 500 milliamps, go like 50 or 60 mils, okay? I say that there, yep. Rule of thumb is if you need extra current, double the trace size. Save. And now you have these tools up here, okay? Now let's start drawing. Oh yeah, grid size. Don't forget grid size. If someone's having trouble with grid size, I'll tell you that. Okay, let's start drawing. Okay, let's draw with a wire. Look at that. That's my pencils. Let's use a 20 mils. That's nice. You have top copper and bottom copper. Those are the only two you're going to be dealing with. You can press that or you can press this. Never mind. Anyways, here's your grid size. See my grid right here. You see my the crosshairs. That's 20 milliinches. Let me go to 50 milliinches. You see now it's doubling, right? Let's do 200. You see that crosshair, right? Let's go back down to 20. I like 20. Is that good with everybody? 20 millinches, right? For my grid. Now let's do a wire. V out, V in. Ew. Let me just click on this. R. I'm gonna do this. Does anyone bother if I do this? Let me see. Delete. Did everyone see that? I just deleted the text. I don't like that. Okay, the text was annoying me. You see this VN right there? That VN right there? Let's start connecting. There's my 20 mils. Press this one. X. Route single track. Let's press X. Yeah, let's go. We're doing it. What about here? X. Boom. Is that cool? Not too hard? Pretty fun, right? It's okay. We'll get there. What about this guy? X. Actually, let me see. What did I do in my tutorial? Using vias. Let's see. With the top copper on, press right here. Press the V key to create a via. So before I do that, go to via right here. Let's use 80. All right. Let me show you what's going on. Oh. I'm gonna press with the top copper X. Actually, let me do something thicker. 40. Let's press X. You like that? Extra thick. Let's click. Let's press V right here. Click. Boom, baby. Like that. We went underground. We're on level 2, the bottom floor. All right. Now our wires are doing something crazy cool. Okay. Is that cool with everybody? See, what else did I do in my tutorial? Oh, I just connected that. Whatever. How do we connect ground? How do we get to ground? With a terminal, right? Or a connector, right? Is that correct? Save. Yeah, let's do this. Let's go back to schematic. Press this button right here. Switch to schematic editor. Boom. I'm going to do something funny. I'm going to Control C. Control V. Let's label this to ground. Boom, boom. Boom, boom. Boom, boom. And is it GND? Is it going to let me do this one? Let me see. Check and save. It worked. Okay, great. Is everyone clear with that? Right? Double click on this. Footprint's correct. Everything's correct. We're ready. Go back to our layout editor. Right? What are we going to do? Update PCB from schematic. Click. Press OK or update PCB. No errors. Ooh, scary, huh? I'm going to do that right here. Give me some space. Right there. What am I going to do next? I'm going to delete that label because I hate it. What am I going to do here? G and D, right? I'm going to wire them together. Press X. Boom. You know what? I'm going to do something funny. I'm going to go to B right here. I'm going to do it on the bottom. Boom. Double stamp. Boom. Easy. Right? Now it's short on the top and the bottom. Like this. Right? What am I going to do next? X. Yeah, there. Boom. We're done. Is that cool? Any questions about that? Save. What did I do in my next lab? We need to realize our board now, okay? We need to cut this. So this is very important. I want y'all to know this. This is the only way to realize your board is you need to put an edge cut, okay? You're going to click on this edge cut button, press a rectangle, okay? I think this class I'm going to show you guys a special edition, okay? So let's look at your layout, right? I'm going to press, where is it? Edge cuts, right? Press this rectangle here, and boom. Is that good? Right? Not so sure if you did it right. Click on View and 3D Viewer. Save, 3D Viewer. What you think? Hey, it's not the lab. It's because I told you what to do, so we'd save like 30 minutes. All right? I want to get to the next part really soon. That's your PCB. Congratulations. You should feel proud of yourself, all right? J1, J2, R1, R2, correct? Let's see. What else did I make you do? Yeah, you see, we skipped all this. You see? We did this in the beginning. We're fine. This is the next important thing. Ground planes, okay? Professionally, there's ground planes on the top and the bottom of your microcontrollers. Look at your microcontroller. You're going to see this ground plane, okay? I'm going to force this to everybody. If you're a power team that's dealing with like a million or like an amp of current, I don't think you need to worry about it. If you're building a drone, don't worry about this either. Because we had someone build a drone with this application. It was really cool. They did like this cool shape. And I was like, don't use a ground plane. It's going to make your drone too heavy. So just use really thick copper wires. So you can do a lot of cool things. But for this class, I want everyone to do a ground plane, okay? Let's click on this button right here and this button right here. I'll show you. Let's click right here. FCU, right? Top copper. Click on filled zone. Let's draw a square. Let's click here. This is going to pop up. We're going to click on FCU and BCU. Click on that one. And click on G and D. Okay? Press OK. Now let's create a box. Okay, double click or click right here. Click once. See the shapes coming up? Click once right there. Boom, boom, boom. And click right there. Boom. And then the final point, I'll just double click right there. And there we go. We're good. You like that? There's one more step we got to do. Press B to fill. Watch the magic. Boom, baby. Let's go. It's looking good. Okay? When you add a copper plate too, you also reduce the manufacturing time as well. Okay? So they're not going to add copper. They're not adding copper. They give you a default copper plate and they're etching copper. Okay? So you're actually making their job a lot easier by doing these types of planes. Okay? Does that make sense with everybody? So they don't tell you this, but that's something that like it makes their job easier and then can print the next student's board, all right? What's this right here? V in? You like that? You like that V out? What happened here? There's nothing there, right? Let me just click on this eyeball. Hide all copper layers. Hide all except the active. You like that? What about this one? Is that cool? And it's not cool as this. 3D viewer. You see that right there? That's how I can tell. I already had to ding 1 point off a senior design team because I was like, where's your top copper? And they're like, oh no. See, I can see, you see that rail? That's what it's going to look like in real life. What about the back? I see. Cool? Any questions? Let's see. Adding text. So you as an engineer, you're not going to remember this in 3 weeks. I promise you that. You're going to be probably, I don't know, maybe going to Hawaii or something and enjoying that spring break and, or San Diego, okay? Make this lab easy for you, okay? So add text. I'm gonna put my first board, or I'm gonna call it. Okay. Click on layers. Oh no. Right click, show all copper layers, or hello, show all layers. Boom. Okay. Let's add text. Where's my text tool? Edit tool. Where's my text button, y'all? Edit text and graphics properties. What the heck? Place. There we go. Draw text. Okay. I'm gonna call this one EE 320 Lab Mondays. Okay. Oh, oops! I did a mistake. Place. Draw text. EE 320 Lab Monday, and then I'm gonna do this. March 2nd, 2026. Before you do anything, before you press OK, press this button right here. Put it on F silkscreen for front, the top, the front silkscreen, right? This is the text. If you looked at the cactus or the Shrek, that's silkscreen, okay? That's the text you're gonna be printing, okay? It's not ink, it's silkscreen. So click on that. You can make it bold, unbold, whatever. You can reverse it. You can do this. Same thing. Orientation too. Okay? You like that? Yeah, it's a little too big. I'm gonna properties. Let's make it smaller. Let's make it I don't know, 40 by 40. Okay? What do you mean? It will be clamped. Whatever. Whatever. It's fine. Oh, you know why it's saying clamped? Look at this A. It's saying, hey, maybe you'll have an error. Design as best as you please. Okay. Let's do a 44. Is that good? Cool. What am I gonna do on the back? Let's do something. Place, text. I'm gonna put by David or something like that, right? And Monday Labs. Smiley face. I'm gonna do something fun. Back silk screen for the back of the board. I'm gonna reverse it. Okay, reversed. And let's OK it. And let's put this right here. Is that cool? Save. View, 3D viewer. What are we gonna get? Look at that. Cool? What about this resistor? If you're lazy like me, you can just do the following. Or, let's do this. Reference, value, 1K. Right? Is that gonna print? I don't know. Let me check. Let me check if this is gonna print. It did not print. It did not print. Let me just click on it again. Oh, ooh. So there's some manufacturers. There's one team in my senior design. You can contact the manufacturer to tie the data sheet, the footprint, and a value, and they'll put it in for you. That's expensive. Their board costed only like $20, right? $20, not too bad. But they're to put the places, the parts, and everything, bump them up to like $250. So, but you can do some mass production with like special fabricators. For us though, we're gonna solder our own pieces. We have all of them here, okay? So, do I want to do something here? Nah. Let's do the following. Place. So I want to finish this lab. Draw text. Control Shift T. 1K resistor. Or just do 1K, whatever. On the top. Okay, you guys like that? 1K. Is that cool? So do your best. Have fun. I'm just showing you what you can do. Okay. View, footprint, 3D editor. You like that? 1K. Cute. Let's get down to the next part. Let me see. Adding UNLV logo, because Dean Venkat's gonna be like, whoa, what are you guys doing? Let me just do a sanity check. We're still recording. Cool. Let's add the UNLV logo, okay? Let's right click on this. Get the file. Oh, it's gonna download the zip file, okay? Let it do its thing. What do you mean 1 hour? Download 1 hour. Who's designing all this? Pixel by pixel. Do you think it's a bitmap, BMP? Who knows what bitmap is? It's a special like protocol where they're just setting the bits of every like cell. What's JPEG? I think JPEG stands for some engineering. I forgot. I watched this cool video. It was really nice. Man, our Wi-Fi's slow. Let me just... Anyways, let me read through this. You can download pictures. You can download logos. If you're designing your own company logo, right? You can create a footprint from a logo. And all you do is press this image converter, right? Right? Image converter. If you click on this, you can put a file in here, which is source, and you can convert from picture to a footprint, okay? That's how someone put Shrek on there. It's really cool. Okay? Make your board as happy as you want it to be. There you go. Downloaded. Control X. KiCAD. Boom. Downloaded parts, right? It's a downloaded part. I already have it right here, but let me do it again. What should I rename it as? UNLV logos. Extract. Enter. Whatever. What do I want? I just want the PNG. Not the JPEG. Not the color. It can't do color. Let's do this one right here. PNG. Black. So let's go here. Here's our image converter, right? Just make it smaller. It's not letting me. Whatever. Source image. Right? Let me go out of here. Downloaded parts, right? Oh, 2025. Wrong class. 2026. Downloaded parts. Here's my logo. UNLV logos, right? Just to show you that I'm doing something unique. Here's my PNG file. Click, open. What did I say in the lab manual? Inches. Let's set 1 inch. Footprint, silk screen. UNLV logo. Okay, let's do that. 1 inch. Set to 1 inch, and boom, it auto does that, okay? Footprint, F silk screen, correct? If you wanted to do a funny thing where you want to do like a mask, you can. What do you call it? Or if you wanted to, so there's some PCBs where some people use like copper to draw things. Be very dangerous. Be careful with that. It could be dangerous, but anyways, there's a lot of cool things. But let's just do silk screen. Just very basic. I want to go home. Or actually, no, I have another class to teach after this. Export the file. Let's go to 2026, Lab 5, KiCAD PCBs, downloaded parts. Let's call this my UNLV logo. Okay? Save. Let it do its thing. I think I already did it. Oh, wait. Did it do it? Exit out. Whatever. Preferences. Footprint library. Plus. My UNLV logo. Right? Let's go find that footprint. Where did I put it? Let me do something funny. Sorry. Where did I put it? Right here? My UNLV logo? Oh, whoa, whoa. Heck is this? Logo. Example logo. Did I create all of this? No, wait, no, this was from 2025. Whatever. I've already done this way too much. My UNLV logo. Click on this folder. Boom, 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 boom. Wait, F5. KiCAD PCBs. Where did I put it? Right here. Downloaded parts. I'm not gonna like that one. Whatever. Okay it. Let it do its thing. Cool. Let's go back to our layout. Where am I gonna put this logo? Press A. Press A for objects, right? My UNLV logo. And then look, I did other ones here too. See? Everyone cool? Click on this. Show in 3D viewer. Whatever. Stamp that puppy. You guys see that G right there? Delete. Save. View. 3D viewer. Any questions? Do you think this is going to give us an error? Yeah? Be my guest. Let me see. Boom, right there. That's okay. What's the next part? Am I at Rev 2 already? Final PCB. Rev 2! Who's ready? This is the new content I was working on literally till like 3 in the morning last week. If you guys want to go a restroom break, be my guest. But actually, nah, don't worry. We're going to go right into this. I want to finish this in 1 hour. Let's see. Let's add a new component. We're going to be doing the op amp, okay? This is the op amp right here. You can click here for the link. Right? Here's your models. Here's your data sheet, right? Click on this. I don't think I'm going to do this because I don't want to waste too much time. I want to finish designing, okay? Error. Unless someone wants me to do it. Download the file. Note the footprint, right? Is it downloading? Come on. Which one am I downloading? Ultra Librarian. Let's click on Ultra Librarian. Let's download that. I'm going to download it again. Step file, KiCAD V6. Download. I want to make sure this is easy for everybody, okay? Okay, it didn't download that too bad. Okay. Control X. My parts, downloaded parts. Paste that right here. What am I going to call this one? My op amp. Extract. Extract all. Extract here. Boom. Yada, yada, yada. KiCAD V6. That's my step file. My symbol. My footprint. I think there's a problem with this footprint. It's okay. Don't worry. Let's go to the library. Extracting the file. Da-da-dum. Let's just add this thing, okay? I need to finish this, okay? I don't want to spend too much time. Go to our main KiCAD menu. Preferences. Manage symbol library. Add. Let's do my op amps. This right here is our symbol. Okay? Let's go here. Downloaded parts. My op amps. KiCAD V6. Symbol. Done? Okay it. Come on. Let's go to preferences again. Footprint library. Plus my op amps. Boom. Downloaded parts. My op amps. Footprint pretty. Okay it. Because I think this is going to generate an error. Let's see. And let me just go to symbol editor. And let me just check. What did I do? Because I don't want to waste time. Our footprint is giving us a bad model. Download the other file. But before we do that, let's skip this part and let's download the next part. This right here is a dip socket, 2x4 dip socket. Okay, click on this link right here because we're gonna do something different. Okay, TT models. Let's download this. There's our footprint. I like that one. No, I don't like. Okay, it's spinning. It's spinning. Let it spin. Come on. There we go. That's not right. What the heck? This one. I'm gonna do something funny. I'm gonna download this one right here, okay? The step file. Okay? Click on this. Control X. Downloaded parts. Paste here. Call this one my dip socket. Right? This. Extract all. Boom. There's my step file, right? My dip socket step file. I'm gonna do something unique. Maybe I'm gonna tell the other lab too. Okay, everyone paying attention. Go to Ultra Librarian. Okay, this is new. This is not in the lab manual. I'm gonna do this for my own personal pleasure. I'm gonna download this one. I don't want the 3D model. I want KiCAD. Okay, I'm just getting the footprint. Okay, this is a more special topic. Be careful what we're doing. I'm gonna rename it right here. This is my what do you call it? My I'm gonna call it my LM or my dip socket footprint. Okay, because I only want the footprint. Okay, this is what I'm doing. Paste that right there. Okay. Extract all, enter, boom, let it do its thing. I only want the footprints. Let's do some advanced KiCAD stuff because I haven't done this, but we're going to go crazy. Manage symbol. My op amp, right? That's our op amp. Let me just click on it. Let me just check on it. Symbol, we are good. Okay, let me just okay, I'm doing the symbol right now, okay? This is the symbol. Let it do its thing. Let's go to symbol editor. Let's type in my op amps. There we go, looking good. We need to tie this symbol to a footprint, right? So what I'm gonna do is I'm gonna go to properties, footprints. I'm gonna click on this. We need to assign this to that dip socket, okay? Ooh, whatever. It's saying, you wanna know why I got that error? I generated it in the lab report, in the lab document. It says it's a bad file. And sometimes you're going to encounter that. You're going to have a bad manufacturer. I'm going to write in an email being like, your op amp sucks or whatever, okay? I'm going to help you solve this, okay? My dip socket, correct? Or what was it called? Dip socket?
It was called my dip socket footprint.
Footprint? Let me see. Where is it? Where is my thing? My dip. Where is it? Unless I need to actually instantiate it. Let me go here. Okay, this is new stuff. Okay, I'm choking right now. Okay. I'm gonna add something right here. Press the plus button. My dip socket footprint. Okay? Press this plus button. Let's go find that dip socket, okay? My dip socket footprint. KiCAD footprint. Okay it. We're good. Okay, this is new stuff. This is not in the manual. Let's go back to the symbol editor. Let's go back to here, symbol properties. Double click the footprints. It's gonna start crying, be like, oh, I got an error. Whatever. My dip socket. There we go. You see what happened right there? You need to set the path from the main menu, else you can't find it in your component library. Does that make sense? Okay? I'm generating these errors so that you don't go through these errors too, okay? 3D viewer. No, because it doesn't exist. Is that cool? That's my master footprint. Okay? Save. We're done. Let's go to footprint editor. We need to make this op amp look cute, right? Let's do it. What do you call it? My op amp? Is that what I called it? No, let's do this. My dip. There we go. Is that cool? That's the one I want. I'm gonna go to file. I'm going to footprint properties. Right? You look cute, right? Let's go to 3D models. I'm gonna add the dip socket, okay? Where's my dip socket? Right here, dip socket. My step file. Okay it? Boom, looking cute, right? Not really. Let's flip it on its side. Or this one. Let me see. Scroll down. Come on. Ugh, this thing sucks. Come on. Oh, no, it's not going to let me select it. You're kidding me, eh? Come on. Come on. There we go. You guys following what I'm doing? Got to put it in the holes. Let's rotate it. Not that rotation. Not that rotation. That rotation, right? Do you see that little hole right here? That's the top of your IC. So we got to flip it the other way. Like this. Or... Is that cool with everybody? Right? So I'm going to move it around. Move it down like this. Maybe move it this. Down like that. Move it like that. Is that cool? We're getting there. We got to put it in the holes now, okay? Boom. 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 Is that almost there? Got to move it here. Boom. Let's put it down. Lift off. A little too deep. Whatever. Is that cute? Let's put it up. Cool, right? What else am I going to do? Let's add the actual op amp. Okay? So press on this plus button right here. We're going to add the op amp itself. We're going to make it really, really cool. Where's my op amp? My op amp right here. P0008A. P0008A. Does that look cool? See how there's a dip right there? Right? You see it? Right? Let's do the same thing again. My eyes are getting dizzy. There we go. Let's go up. Let her fly. Whee. Boom. Boom. You guys like this class? No, it's boring. I'm gonna go home. Yeah, it happens. I know. I want to go home too, but I'm paid to talk to y'all for 2 hours and 45 minutes. Does that look good? Punch her in. And one more. Does that look good? Do you know what we just did right here? We just verified that these op amps that I bought are going to fit this dip switch. You like that? I like it when things work. So we did all that hard work, right? Okay it? Boom, we're done. Just make sure that this footprint You see it says con underscore A 08 LC, whatever that thing's called. Make sure that this is tied to the symbol. Save, yes. Let's go back to the symbol. I'm having trust issues. My op amp. That's my op amp, right? File, symbol, footprints. Sometimes David makes mistakes too. Is that correct? Con A, yep, that's correct, right? Help me out. Yes! Oh! You like that? That's our symbol, our footprint, and our 3D viewer. Congratulations, y'all. You can do senior design now, okay? We're done. Let's get back to the works, okay? That was too painful. That's called Rev 2, all right? That's something I wanted to add to this lab. What's another thing I added to this lab? Adding additional headers. So you guys know how we have the breadboards, right? I'm trying to mimic a breadboard. So you can download this file right here, a 2x4 header. Download that. Right? Cute. I'm going to download this, okay? I'm doing it just like you. Ultra Librarian. And I need the symbol, the footprint, and the 3D model. So let's click on this one because this one just was the first one that popped up. Step file, KiCAD D6. Boom. Whatever. Just download this one. Oh, ew, I don't like that one. Let's download this one. Okay, this one's good. I like this one. What am I going to call this one? My 2x4 header, right? Right? Control X, KiCAD, PCBs, downloaded parts, posted right here. There's my header. Control Z, extract all, enter, boom. Symbol, step, mod. Cool? Anyways. Grrr. Let's go back to our main menu. This is a lot of setup, okay? This is going to look cool. Preferences, symbol library, add my 2x4 header. Right? Boom, boom. Let's go to my header, right? Where is it? Right there. Symbol. Okay it. Convolution. If anyone took that to Stubrude. Preferences. Manage footprint libraries. My 2x4 underscore headers. Folder right there. Boom, boom, boom. Yada da da. There it is. Select. Okay it. We're good. Let it do its thing. Symbol editor. I know this is a lot of setup. I know, but I promise you, it's gonna be good for you in the long run. What was it called? My 2x4. Double click. Cute. File. Symbol property. Footprint. Oopsie daisy. We gotta assign it the footprint. We got another error. That ain't good. My 2x4. There we go. You see the errors are happening because we keep renaming little things. If you want to take the time to go figure that out, be my guest, but I'm just showing you what I know, okay? That's our footprint. Okay it. Okay it. Save. Exit. Footprint editor. Let's go to my 2x4. Double click. File. Footprint properties. Nothing there, right? Plus, on the 3D models, here. And then let's go to my 2x4 header. Where is it? Click on the dot step. Hey, that one worked. Oopsie days. Oh. Come on. Wrong one. Oh. Come on. Ugh. Don't you just like it when KiCAD does some funny things? There it is. Does that look good? Any questions about that? Save? Save? We're good. All right, let's get back to designing, okay? Let's go back to the manual. Final schematic editing. This is what I want to see by the end of class, okay? So if you check in with me and Shocky Bowl, you're good for the lab. You're ready for next week, and we're going to purchase these boards. If you haven't finished it, what have you been doing for the past, I don't know, 2 hours? Or let me know, okay? So I'm going to be checking your boards by the end of this class. If you finished it, congratulations. You don't have to worry about this until next week. You can just see me next week, and next week's lab is super easy. You can go home, all right? Once I check you off and buy your board, go home, all right? So technically, you can make next week a no lab week if you just finish everything on time, okay? But if you haven't finished it, you're going to have to check in with me today up until Thursday. And else, if you don't do this design check, I'm going to be very strict about this because I already had one person. A Gerber design review will be done this week between now and March 5th. Failure to follow this is an automatic 50% deduction. Is that clear with everybody? I want to make sure you guys have boards that are working. I had a team and they were like, a design review, but you're purchasing it the next week? So it's due next week, right? No, I need to make sure it can print. And then I'm a very nice person when it comes to just giving you the chance. Their board failed. And then they couldn't solder it. Then they failed both the labs. And then they just stopped showing up. And I didn't like that. I felt really bad because I'm like, you got to check in with me, okay? I want to make sure you guys are following the steps as best as you can, okay? This lab is a little more easier because I guide you really hard into one pipeline. So by the end of this lab session today, you guys are chilling, okay? Failure to submit a board with me that day is an automatic 0 for the lab. This lab experiment, okay? However, there is a clause, so if I do have a 0 for a team, there is a way for me to get you boards. Everyone's doing the same schematic. You're gonna get, if a team wants to do a bonus point thing, you can donate your PCB to the team that lost all their points, okay? Does that make sense? That's something I'm doing for this semester, so we don't have double dingers. If you fail lab 5, you fail lab 7. I don't want that happening again. I want everyone to solder a board, okay? So don't do a thing where, hey, if you just fail the lab and help me out. No, we're not doing that, okay? I want everyone to have a cool board so I can show Dean Venkat we can keep doing this every year. Make sense with everybody? Anyways, let's finish this. Control F, final schematic. Let's add that op amp. Going back right here to our schematic, right? Let's press A. Let's add that my op amp. You see how easy this is now? Boom, done. You see, we did all that hard work, and now we're just designing things. What else did I do in my lab? Look at that milk. Oh, it's so beautiful. Let's add headers. So I'm going to press A, my 2x4 header. Milk. Ow, it's looking milky, eh? Boom. That's my feed forward. Copy paste. Copy paste. Boom. I'm gonna put this right here. Something's wrong. Let me see. It's okay. Okay, we're fine. And right here, copy paste. Guys like that right there? I'm gonna put this right here. M to move. Ooh. I like my little lab manual law. It's really cute, really nice. Boom, boom, boom. And then what else did I do in my lab manual? We're doing a feedback path. Do you see this minus terminal? That's why they failed the lab, because they put the plus to the output. They did positive feedback. Failed the PCB lab, failed the verification lab. They're like, whoops, my thing's saturated. Verify your things. Luckily for you guys, I'm not making you guys do a simulation for this lab. I did it for the last year's lab, but this one, don't worry. Just follow this tutorial. You guys are being techs for now, okay? When you're doing your senior designs, you're going to have to do your own simulations. I'll be clear with this. This is not a simulator. This is just a design tool. There is a simulator tool, but I haven't dug into that yet. You can use LT-Spice to simulate everything so that your designs, when you're doing your PCB, you're good. Any questions about that? Cool? Anyways, negative terminal to here and here. That's the negative terminal. I'm going to connect it from here to here. I'm going to connect this from here to here, right? And then what am I going to do with these terminals? I'm going to short them like this, right? Because that's how I'm designing my board. W, boom, 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 boom. Is that cool with everybody? Are you guys seeing the pattern I'm trying to do? Hey, how do I short this? Just when you build your PCB, you're going to use these jumper wires to short that header, okay? So you can, this is a universal op-amp design. All right, I want to see this work. I'm actually really excited. Okay. I'm going to press W here. Boom, 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 boom. Like that, like that, like that. What am I going to do with this output? Connected right here. Boom, boom, boom. Any questions about that? What about this guy right here? Why did I put this here? Let me click M. Let me press rotate. Now, is that what I did in the lab? Yeah, I rotated this. Boom, 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 boom. So right here, I know it's a lot of clicking, I know, but once you already have the hard part done, we're golden. All right. Press W here. Boom. And then I think that's it, right? No, we need to add a header. So the op amp is going to drive some current. It's going to drive like maybe, I'm going to say like 500 milliamps maximum, okay? So we're going to have a stronger connection. What am I going to do? Copy one of these guys. Control C. Control V right here. RR. I'm going to do the following. Do this. Double click. I'm going to label this right here as VDD plus, right? What am I going to do to the bottom pin? Pin 4. Label VDD minus. Right there, right? Boom. Boom. Is that cool? Move this a little bit right here. Well, I'm going to name this top pin right here. VDD plus. Right? Oh, oopsie daisies. Delete. VDD plus. Okay. What about this one? VDD minus. Is that cool with everybody? There's another thing you need to know, and this is why I'm doing this tutorial, because last semester we did the op amp, but this team didn't know how to do the schematic because they're like, I can't figure it out. So that's why I'm doing it right here in person, recorded in video. All right. You see these two terminals right here? It's gonna give you an ERC error. How to get rid of that? Press this button right here. Place no connection flags. Right here. I'm gonna have to drink some water after this. Place your flags right there. Woo! I'm sounding like I'm like my Wednesday night classes here, right? Who has my 360? Yeah, we're having an exam review. There we go. Boom. W there. Double click. Is that cool with everybody? What's the next thing I gotta do? Labels. I'm gonna do V. Oh, what did I do? I didn't do V out. Don't do V out. Do out. Why? Anyone know why I'm doing out instead of V out? Let me click on label net or this highlight net list. If you put V out here, you're gonna accidentally connect this voltage divider. We don't want to do that, okay? Someone's gonna complain to me like an hour before the thing is due, saying my voltage divider and this are shorting. It's the labels, okay? The schematic editor is great for helping you design your layout. All right? What am I going to do to this terminal right here? What do you call it? I'm going to call this input. I'm going to call it input. Is that cool with everybody? Am I going to put a header for input and output? Should I? Yes or no? What do you guys think? Should I? Because I don't think I did that for the lab tutorial, correct? Yeah, I didn't do that. Because you want to know why I was thinking? If you have like a resistor component right here, right? You can treat one side as like, this is your input, right? And this is going into the PCB. Or I mean, let me just go into the camera. Wrong camera. This would be your input right here, right? Right? This is your probe, your VDD, right? Or your signal generator, right? This would be connected to that header. Is that clear? Actually, you see this header right here? You connect this to here, and then this is what's going to go in your PCB, like that. Does that make sense? That's what I'm trying to do with that right there. So, should I make a header? Yes or no? You tell me. No? Yes? And it's gonna cost like 50 cents each. Let's not do it. Anyways, let me see. Because you short this is gonna create. Okay, look. Hear me out. If you put a resistor right here, right? Here's a resistor right here, right? And you put it right. Let me just show you on a design. I'm tired of this. Boom. Don't do what I'm about to do. Control C. Control V right here. Does everyone understand why I'm doing this? I'm going to show you the reason why. Can you agree that if I connect this like this, that this is connected, right? And then if I do the same thing right here, right? Control C. Control V. I'm going to put it right here. I'm going to break some rules. Can everyone agree that this right here kind of looks like the inverting op amp, right? How about this one? Can everyone agree if I shorted this with a jumper wire, that that's shorted? What am I going to call this one right here? I'm going to call this one, what am I going to call this one? What did I call it in the lab? I called it plus. Plus. Right there. And I'm going to call this one, what am I going to call this one? Pause. For positive, right? This one is negative. Right? Is everyone understanding? What does this plus look like right here? If I shorted this with this, right? That's my ground, right? The ground goes to the plus terminal of the op amp. Does everyone agree? Who doesn't understand? Good? That's what I'm trying to do, okay? So when you're getting your boards, we're going to short this to this with a jumper wire, okay? So I'm going to delete this, delete that, okay? I'm just showing you why I'm doing this, okay? Delete all of this. Boom, boom, because I want to get done. I'm trying to debate if I want to do this again on Thursday. I don't think I will. So yeah, congratulations, Monday Lab. You guys are my special lab, all right? So if you follow this along, you'll probably be done with the lab right now. I don't think I'm going to do this for Thursday because my voice is cracking. Do you think this is going to run? I don't know. Let's do an ERC. Ooh. You know why I got these errors?
The ERC is a liar.
Yeah, that too. But power flags. Where do I get them? Pressing A, right? But I'm too lazy. I want to go home. Control C. I'm going to put that right here. Control V. Boom. I don't like that. Let me just move. I'm going to put that right here. Is anyone bothered if I do that? I'm not. Yeah, let me just move this a little down there. Is that cool? ERC? Run? Who's ready to design? Save. Don't forget to save. Let's go back to our layout. We're finally about to finish this PCB. Go to this button right here, update PCB from schematic. Update PCB. One error. What do you mean one error? Who cares? That's our board right there, right? Put it right here because I'm too lazy. We need to make, sometimes you're going to do your senior design and you need to make edits to your board. How do I edit this board? It's easy. Just do this. Just stretch them. Oh, ooh, I'm getting the error. What the heck? What the heck? Oh, that's dumb. Stretch your wires like that. Let me press B. Is that cool with everybody? Anyways, let's finish this lab. Delete, delete, delete. What did I do in my lab report? Let's see, what piece is this what? This is my input, okay? I'm gonna R it, okay? That's my input, that's my negative. This is my plus and my positive. How did I design it? Let's see. Where's my final design? Right here? You guys like that design? It's pretty cute. So this right here is this right here is that. Okay, got it. So is anyone going to be mad if I do the following? Is that right there? Delete this. Delete that. Delete that. Press R to rotate. M. This goes right here. Press M to move. R to rotate. I'm gonna move this 320 thing. I'm gonna move this. Yeah, I'll just move it right here. Is that cool? And then I'm gonna press B. If you press B right now, watch what happens. Looks a little more cleaner, okay? Makes your labs look a lot nicer. Move that right there. Move this right here. Maybe move this a little right there. I think I put the power pins right this. I'm gonna rotate, boom. I like that. Looking nice. Plus. Positive. I'm gonna B for fill. Is that looking like what I had in the lab? Right? What about this pin right here? What's this guy right here? It's my ground. Rotate. Does it matter? Maybe. Move this right here because I have a little bit of OCPD. B it. Does anyone know what happened to the ground? Look at that. It created these little things. So you remember that trail we made for the ground? Like it was a big snake, right? It disappeared. Well, I deleted it, right? But do you see how it's integrated to the whole PCB? Ah, now the whole PCB is grounded. Who's ready to design? Here's my VDD, right? You're gonna use really thick VDDs, okay? So I'm gonna use, let's use 60, okay? And I need to connect this right here to this VDD plus. Let me see. Where's my cheat sheet? Okay, I went around like this. Cool. So I'm gonna do X route. Boom, like this. Oh, come on. Come on. You like that? Looking good, huh? What about this other one? VDD minus. X. Boom. Is that looking good? Is that what I did? Yeah, boom, boom. Done. How about this guy right here? This is going to be our ground, right? So we're going to make it a little thick. Boom. 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 And then boom. That should work. And then I'm going to do something funny. I'm going to make little mini trails just so I don't create too much pressure. I think I like that. You see that corner right there? Just make it like a pseudo ground plane. Let me press B. You see that right there? That's my ground, okay? I'm using the positive terminal of the op amp as my ground, right? Do the same thing right here. So I'm going to go back to 80 mils, or was it 60? X60. Boom, boom, boom. Just connect them like this. Ooh, can I do this? Let me see. Ooh, I like that. That's clean. Ooh, I like that. Ooh, I like that a lot. All right, let's do it again. Boom, boom. You see, I'm learning too, y'all. Boom, boom. There we go. That looks nice. I think I like that. I think I like this tech. Boom. Actually, let me do that again. I really like what I'm doing right here. It's really cool. Or let me do this. Boom. You got to short them out. There. Yeah, I like that. That's really clean. Okay. Boom. Short them out like this. Yeah, this is looking like milk, y'all. Milk and honey. Oh, oh, oh. There we go. Boom. 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 Is that looking good, everybody? I got to connect this to my output. How did I do that? Let me see. What did I do? What magic did I do? Oh, yeah. You see that right there? I put the output going underground, right? On level 2, on the bottom floor. So how am I going to do that? Going to change this to the bottom copper, right? Let's do the same thing right here. Boom. 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 Let me do the same to Paul. I really like this. This is really cool. Like that, right? And let me just do this. Right there. There you go. Beat a bit. Beat a build filled. You guys like that? I like it. Let me do the same thing right here. Boom. 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 Beat a fill. You guys like that? Do the same thing right here. Boom. 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 And then what am I going to do to these two negative terminals? Connect them. Let me see if I can do something funny. I don't like this. I don't like this. Because this is going to create an antenna. I can see it. This is an antenna, so noise is going to go through this. Remember, what was that, Ampere's law? Yeah, this is an antenna. Do I like that? I don't. If you go RF, you'll understand what I mean. You want to know? I'm gonna do this. I'm gonna do then. I'm gonna make this really thick. Oh, delete that. X. There we go. X. There you go. I like that. That's a little better. So there's this thing called ground loops, and that's ground loops basically is when you put ground here and circle ground, and you can create an antenna. You can create PCBs that act like noise generators, and you'll wonder why your thing doesn't work. Like breadboards, for example, if you put a ground around your breadboard, you unironically create an antenna. That's why you're getting bad readings, okay? So try to reduce. This is not a super professional. I'm just trying to quick start you guys. But there's things like S parameters. There's impedance matching. There's other things. But right now I'm just showing you what I can, okay? So I'm going to connect this. X. Come on. X. Now it's not fitting where I want it to go. Boom. Oh, I don't like that. 60. Boom. Boom, baby. Let's go. B to fill. I think we're done. We're done, everybody. Are we done? Maybe. Let's add some text. Can everyone agree that when you guys come back from your, I don't know, trip to Hawaii or something, you're not going to remember what's this, what's that? Let's add some text. Place, text. Call this one input, right? On the top top silk screen. I'm going to make this 30 by 30, right? Then it'll bark at me, don't worry. This is my input right here, correct? What about this part right here? I'm going to copy, paste. I'm going to put this right here. I'm going to call this one, this is going to be plus GND or / GND. Does everyone understand what I'm trying to do right there? So then when we ground the op amp, right, we're going to ground this. This is the plus side of the op amp, right? Cool? Or if you wanted to do a non-inverting op amp, you can put a resistor right here, wiggle the input right there, you're done. Cool? You know what I'm going to do here? I'm going to do this. Input under this one, I'm going to put neg. Negative. Is that good? Or should I do minus? Yeah, I'll do minus. Does that look nice? Then what I'm going to put right here, I'm going to do place, draw text, feed back, right? Let me do top silk screen. Let me do this on 25 by 25. Oh. Yeah, whatever. Feedback right there. Is that cool? Then I'm going to copy, paste right here. I'm going to call this one feed forward for myself. Okay? We're going to put a feed forward resistor, right? R input, feedback, RF, your integrator, differentiator. Correct? What about this guy? VDD minus, right? We don't want to fry the chip, correct? So let's put a note for ourselves. I wish I could press T. No. Place, text. This one's going to be, what do you call it? Elf silk screen. This is going to be, I'm going to do 9 volts plus 9 volts, okay? Because I'm going to put 9 volts on the op amp, right? You see this right here? I'm going to put this right here. That's the 9 volt terminal. I'm going to copy paste again. I'm going to put this right here as minus 9. Oh. Okay. Is that cool with everybody? What am I going to do right here? I'm going to click this, Control C, Control V. I'm going to put this as output, right, or what do you call it? Right side of this header. Is that cool? Save. Don't forget, it might crash. Who's ready to see this magic? Oh yeah, baby, let's go. Does this make sense with everybody? Am I wasting your guys' time? Or if anyone says, I don't know, you could go for lunch, I don't know. Is this valuable stuff? Am I teaching you guys real stuff? Does Dr. Venke do anything? I think 301. Does he do stuff like this? That's what I'm trying to tie into this class. I'm making a deal with Dr. Venkat, okay? So I can do some more cool projects. I want to see if I can get a big funding project for ECE, okay? You guys are going to help me out a lot. I want to make sure we can do some cool designs. Look at our PCB. Woo! Look at that. 9 volts. What is this pin right here? You know what? Flip it around. You see how it's kind of ugly right there? Flip it around. Don't worry, okay? That's just for us to think about, okay? Just flip it around, okay? That's going to be our minus 9 right here. Plus 9, right? Plus / ground right there, correct? Input / minus, right? Is that cool? And then feedback. This is our feedback thing. So we're going to put our resistor up here. Boom. You see that resistor? It's going to go on top of this. Output on the right side of this header, right? Do you want more notes like this? Do that for yourself, okay? Whatever makes you happier, okay? Because let me see. Do I want to do something funny? I'm going to copy this. My OCPD is kicking. Input minus, let me just do this. Input left side. All right, let me do this. Bridge with R or C component. Is that better? Let me make it smaller. Q. I'm going to do 25 by 25. Okay, it's going to give me an error, whatever. Get rid of this. Screw this. Boom. Control save. Is this a lot better? When you come back from Hawaii, right, or San Diego, is this going to make sense right here? Right? Feed forward, feed back. This is plus and ground. Who's ready to DRC this? One last thing, and I'm going to do, this is the design rule check, so I think a majority of you, if you're not following along, I will give you this note, but if you're following along with this size, how big is this board? Let's do tools, or was it place, view, place, draw dimensions. Do I put a ruler here, inspect, measure board, Control Shift M. How big is this board? I don't know. Let's go to inches. Click on inches. Control Shift M. How much money are you going to pay for me? $1.32? Or no, not $1.32. 1.32 inches, right? By how much? 1.32 by Control Shift M. 1.32. 2.45. Or is it 2.5? 2.5 times, what did I say? 1.32, right? 3.3 square inches. Is that cool with everybody? Osh Park's going to charge me $5 per square inch. So 3 or 5 times 3.3, right? That's about 15-ish dollars, 16, 17, right? Not close to that. And you get 3 of these PCBs, okay? Is that cool with everybody? But I'm going to expedite it. I'm going to try and see if I can get it a little faster. So it's going to cost a little more dying. But anyways, if you have a board that's greater than 4 square inches, I'm going to have to tell you to redesign it, okay? Because I have a budget too that I'm working with, okay? Last semester I did 5, but people were wasting too much space. So this semester I'm strictly putting it to 4. So you can have a 1x4, you can have a 2x2, but smaller is better, saves more money, okay? Any questions about that? Then we can delete this marker and escape, save, DRC. Press this button right here. We're almost done. So we have no errors, but we have some, little warnings we got to take care of. Let's click on this. It doesn't like this. It says height out of range. Text height. Let me see. Remember that one parameter that we were talking about, text height? Remember that user preference text height? I set it to 30 because user preference. So you know what I'm going to do? I'm going to force this. Man, that David guy's crazy. Board setup. I'm going to set it to milli-inches. I'm going to get rid of it. I'm going to put this to 15. Why not? Save. Let's run that tool again. What's going to happen? I got 6. Silk screen is clipping. Oh. It says it's clipping on the back. So all I got to do is just move this. Can I rotate? Yay. It says this logo right here, this thing, and this were clashing. What else? It says this one is overlapping. Do you understand what these things are right here? These are instances. Honestly, I'm just gonna delete it. And then let me see. Think footprint. Let's see, we're good. Okay, I think that was the only error. Okay, here. You see that right there? Monday and J6 are it's just saying, hey y'all, your thing's gonna overlap. Just move it right there. Run it again. What? Oh, do you see that little star? Are you kidding me? Whatever. You know what I'm gonna do? I'm gonna keep that star. I like the star. Wait. Why do I have 2 of them? Why not 2? I'm gonna delete it. Screw this. Run it again. PCB. Boom. I need to see this screenshot here, okay? I need to make sure your thing can DRC, ERC. Those are the 2 most important things I need to see from your lab reports. Post lab 5. I'm gonna make it due that day, but midnight, okay? I'm not gonna make it due before class or at the end of class. I'm gonna make it due at the midnight, okay? Polish your reports, all right? This is what I want to see. When it DRCs, we're ready for fabrication. We're almost done. If you copy this right now, make sure you put your name, your team partner name. What else did I say? The class, the date, right? Okay? You're almost there. I'm going to give you guys your notes, and you guys can go home and not worry about this next week, okay? Yes, there's not any pre-labs next week, but we're purchasing boards. You guys like this? Look at it. What the heck happened here? Uh-oh. Oh, you know what this right here is? That's the via. That's the via for ground. Does everyone understand what's happening? This is connecting the 2 ground planes, the top and the bottom, okay? That's why I was like looking, I was like, what the heck is this? Oh, that's my via. But why? Wait. Something's wrong here. Something's wrong. Oh, sorry. That's my V out. Anyways. Huh? That's good? Anyways, let me show you one more thing. I don't think I put this in the manual. Can we all do this with me? Let's go with 40 mils right here, 40 by 20. I'm going to put a via right here. I'm going to put this in the middle. Double click on it. This is called a ground via, okay? This is going to stamp the top and the bottom vias together, okay? So let me show you what that looks like. Think of it like a tent. Okay, Control C, Control V, Control C. I'm going to put one right here. Control V. I'm going to save, Control S, View. Oh, come on, Escape, View, 3D Editor. See that right there? Those are ground vias. If you have an Arduino, you're going to see these tiny little holes, okay? I don't have one on me, but these are called ground vias, okay? They connect the top and the bottom coppers, all right? Anyways, who's ready for fabrication? Go to File, go to Fabrication Outputs, go to Gerber, okay? We're going to save all these Gerbers to a special file, output directory. We're going to click on this folder button right here. You see, here's my folder right here, KiCAD PCBs. I'm gonna do it right here. Monday special right here. I'm gonna do it right here, I guess. Backups? No, I'm gonna do it right here. I'm gonna call this one EE320L Monday Gerber. Okay. Oh. New folder, whatever. EE320L Monday Gerber. Okay? Select that folder. We're going to dump everything into there. Press no on this next button, okay? Now, let's generate drill files, okay? Press this button. Or wait, no. Don't press that button. Press plot. And it's going to dump everything into that folder. Let me go check. Let me show you. Okay. KiCAD PCBs, Monday special, Gerber. We're ready. We're almost there. One more thing. We got to have the drill files. Okay. Go to generate drill files. In that same folder, just press generate. All right. Make sense? Did it work? Let's run it again. Okay. Escape. Escape. There's my drill. You see these two files right there? That's important. That's the thing that they're going to use this like milling machine to drill holes. You need these two ones to drill holes. These right here is your job. You know, the copper, the bottom, all the text. What's the final step? This is what I'm going to see the final part of your lab report, post lab 5. Compress to zip file. Boom! This is what you're going to be emailing me. There's another submission called Gerber. Put it in there, all right? It's due, I think, the end of that class. Because by the end of this class next week, 12:45, I'm going to swipe my card. Right? Well, maybe plus or minus 5 minutes, all right? You see this folder right here? Let's go to oshpark.com. And you can show me this too in your lab reports, okay? Boom! Let's get started. Drag, click, uploading your design, and this is going to do a final DRC. How to make sure, basically it's going to do its own DRC to say, is your file going to work? Yes or no? And it DRC'd. See? Green check. And guess how much it's going to cost? $16.50. Nice, right? And you get 3 of these boards. Okay, and then I'll show you guys what I'm doing. See, it's going to show you the top board, right? You're going to analyze it. I like it. Okay, it looks good. Bottom board. This is what I'm going to do literally next week or this week, depending on how you meet with me, okay? Definitely next week I'm going to be looking at this because I'm going to know what it is. This is a board outline. If you want to draw a shape, it's going to show you the cuts. So if you saw my lab report, right? Right, this right here. You saw the cuts right here. Let me see. You see these cuts right there? It's going to show you this cut. Or you can have a rounded edge like that, right? I'm going to edit my board again. But anyways, not now because I'm trying to get you guys done. That's your shape. You can create a star. You can create a Christmas tree. Whatever you want. the drills, the top text. You see, do you approve these texts right? The warnings are to say if they overlap. The solder mask, top layer, you see all that metal? You save a lot of time. That's why we have to do the top and the bottom like face planes, okay? You see this? What's this right here? That's our ground. Easy? Exit out of there. And that's our bottom silk screen, okay? Don't forget your names. Order, or save, you can save for later. Order, let me see. And this is extra. I'm just going to show you what I'm doing. C3, I'm going to do the following. I'm going to do for, you're not doing this. I'm going to be doing this right in front of you. I'm going to do super swift service. It's going to double that, okay? Instead of it being $5, it's going to be $10 per square inch, okay? Because I need this before, like when you guys come back from your break. You can also do like dark mode PCBs. Like I think that cactus was dark mode or something, okay? And there's some other cool things you can do. Anyways, what I'm more important about is this right here. That's your final DRC. That's what I want to see. Are there any questions about this lab? Yes?
I've been struggling with the footprint. Like, I cannot add a footprint.
Okay, so that's what you're going to have to talk to me between now to Thursday, because I want to make sure you can do your PCB. Is a majority, okay, who can't? So we got 1, got 2. Okay, so all of you, okay, 3, okay. So you guys have to talk to me, okay? I want to make sure everyone can do a PCB. Any questions? And yes, the video is going to be published. I'm going to be publishing that right after this class. Well, not after. I have other classes to teach. But I will make an announcement. But please, everyone needs to talk to me, all right? And then Shockable, well, do your best to route them to me because I'm the one who's going to be purchasing these boards, okay? Any questions about that? If anyone wants to show me their boards before you guys leave, be my guest, and I'll honestly give you my notes, all right? Have a good day.